if Maxwell wanted to learn something about electricity, he needed to know Michael Faraday. Faraday was a self-taught scientist who was revolutionising our understanding of electricity and magnetism. Maxwell's relationship with them was one of the most fruitful in 19th century science. We'd known about electricity and magnetism since ancient times. Most people had experienced the power of electricity through terrifying lightning storms. And we'd used magnetism in ships' compasses for centuries. Experiment revealed the existence of an invisible field stretching out into thin air. These fields, he thought, were responsible for the experimental results he'd seen. Despite having physical proof, Faraday lacked a mathematical description of how the field was generated, or why it affected things around it. Something observed in the real world. So the first equation described how a static electric charge generates an electric field. And the second, that magnetic poles always come in pairs. The third equation describes how a changing magnetic field generates an electric field. And the fourth equation, that an electric current surrounds itself with a magnetic field. Electric and magnetic fields were inextricably linked. Changes in one created changes in the other. It helped explain so much. When Faraday moved his magnet, he changed the position of the magnetic field, and this triggered an electric field which caused electricity to flow through the wire. And when electricity passed through a wire, it wrapped a magnetic field around it, causing the compass needle to move. Using pure maths, Maxwell had unified electricity and magnetism, and shown there were two aspects of the same thing. A single Maxwell used his equations to show that the fields could fluctuate in time with each other and cause what Maxwell called an electromagnetic wave. He could even measure the speed of the wave. This was a stunning conclusion. Maxwell had explained what light itself was. At the same time, he'd introduced something new to science: electromagnetic waves. And they were destined to change our planet. Problem was, he hadn't physically demonstrated the existence of these waves. It was all in the maths. Physical proof would have to come later. His equations were an astonishing piece of work. The guns may have fired, but it would be a while before they'd be heard. It took more than 20 years before a German scientist called Heinrich Hertz found physical proof for electromagnetic waves. When he was asked what practical use the wave had, he replied, "It's of no use whatsoever. This is just an experiment that proves Maestro Maxwell was right." How wrong he was, because Hertz had discovered radio waves. Marconi invented the radio, and since then we've been using them to spread radio and television all over the planet. But this was just the first in a long list of discoveries. Happy days are here again. Using higher frequency radio waves, we developed radar, which now gets used in everything from aviation to geology. Microwaves were discovered, which we use in cooking and when we use a mobile phone. Infrared is used in thermal imaging and in most TV remote controls. No sign, no evidence of these mysterious electromagnetic waves. Maxwell was asking people to believe that these waves could pass through empty space and affect things at a distance. It was just too much to ask. His equations were initially met with a bewildered silence. 19th century scientists were used to thinking of the world in mechanical terms. Physically tangible objects that could be touched, measured and felt. Flying in the face of that was Maxwell's theory, Based on dense 1871, he left Glenlair for Cambridge, where he designed and built the Cavendish Laboratory, which would be responsible for discoveries that shaped physics in the 20th century. And as its first director, his open-minded approach set the tone for subsequent generations.
I never try to dissuade a man from trying an experiment. If he does not find out what he wants, he may find out something else.
The Cavendish Lab would become a phenomenal success. It's within these walls that we discovered the electron, and later on, the neutron. Watson and Crick were working here when, in 1953, and having got to know the man, I can understand why. You know, I can't blame people for not knowing about James Clerk Maxwell. His is difficult stuff. I just think that given the breadth of his discoveries and the sheer impact they've had, that it's a travesty that Maxwell's name's not up there with Newton and Einstein as one of the greats. Maxwell is Scotland's Einstein.